Welcome! Have you ever wondered how scientists make discoveries? How did people discover microwaves, electricity, or even the structure of atoms? Scientists do not guess randomly. They follow a logical process called the scientific method to investigate questions and solve problems. Today, we'll learn each step of the scientific method and see how it helps scientists make reliable discoveries. Although every scientific investigation is different, most investigations follow a similar pattern called the scientific method. Scientists may repeat steps, skip some steps, or revise their ideas based on new evidence. Science is a process of learning, improving, and testing ideas, not simply finding the right answer. Every scientific investigation begins with a question. Scientists first identify the problem they want to investigate. Many questions begin with why, how, what causes this? Sometimes, a completely unexpected event leads to a scientific discovery. One famous example happened in the 1940s. Engineer Percy Spencer was working with a machine called a magnetron. While standing near the machine, he noticed that the candy bar in his pocket had melted. Instead of ignoring it, he asked an important scientific question. How did the magnetron melt the candy? That simple question eventually led to the invention of the microwave oven. Curiosity often starts scientific discovery. Before performing an investigation, scientists collect as much information as possible. They research what is already known, make observations, and compare information from reliable sources. This helps scientists understand the problem better before proposing an explanation. Good research saves time and leads to better investigations. Now we move to forming a hypothesis. A hypothesis is a possible explanation based on observations and existing knowledge. It is not simply a guess, it is an educated prediction that can be tested. Scientists often write hypotheses using an if-then format. A good hypothesis must be testable. Some hypotheses can be tested immediately. Others may require new technology before they can be investigated. For example, scientists proposed the existence of atoms 2000 years ago, but technology wasn't ready to test it until much later. Now, scientists test the hypothesis. The most common method is through carefully controlled experiments. Experiments examine how changing one factor affects another while keeping everything else the same. Sometimes, like with stars, experiments cannot be performed. In those cases, scientists collect observations and compare them with models and previous data. Whether through experiments or observations, the goal is always the same: collect reliable evidence. Next, we must analyze what we found. After collecting evidence, scientists organize and analyze their data. They often use tables, graphs, and charts to make patterns easier to understand. Scientists record every result, including unexpected ones. Many important discoveries have come from results that were not expected. Carefully organized data helps scientists avoid incorrect conclusions. Finally, scientists compare the evidence with their hypothesis to draw a conclusion. If the evidence supports the hypothesis, confidence in the explanation increases. However, one successful experiment is usually not enough. Other scientists should be able to repeat the experiment and obtain similar results. If the evidence does not support the hypothesis, scientists do not fail. Instead, they revise their hypothesis and try again. Science improves through continuous testing. Scientific discoveries become stronger when scientists share their results. This process is called peer review, where others examine the methods and data. Peer review helps detect mistakes and improves the quality of research. Scientists must also remain objective. They should avoid bias, which happens when personal expectations influence results. Keeping accurate records and repeating experiments help reduce bias. Good science depends on honesty and reliable evidence. So let's review. The scientific method is a continuous process of asking questions, testing ideas, and improving our understanding of the world. It's a journey of discovery. First, identify the problem. Next, gather information. Then, form a hypothesis. Test the hypothesis, analyze the data, draw conclusions. If necessary, revise the hypothesis and investigate again. Let's check your understanding with a quick quiz. I'll ask a question and give you a few moments to think of the answer. Ready? Here we go. Question 1. What is a hypothesis? Question 2. Why do scientists record unexpected results? Question 3. What should scientists do if their hypothesis is not supported by the evidence? Excellent. Remember, science is not about proving yourself right. It is about following evidence wherever it leads. Thank you for watching.